Let's take a look at 2019 AB and BC number 4. This is a related rate problem. And whenever you do our FRQ, it is always a good idea to read the direction. I spent about 2 minutes just reading the directions and think about what they're asking. So part A says find the rate of change of the volume of the water. That's the rate of change of volume of the water with respect to time. So basically we're looking for dV over dt. That's what we're looking for when the height of the water is 4 feet. When the height of the water is 4 feet. So this is what we're looking for. Now, what is the volume of this cylinder? Well, the volume of the cylinder is V equals pi r squared h. Now, when you look at the cylinder, what is changing? Well, the height is changing as the water decreases. What about the diameter? Is diameter changing? No, diameter is always going to be 2 feet. Since the diameter is 2 feet, what is the radius? Well, it's 1, because radius is half of the diameter. Since r is not changing, we could replace r with 1, which gives us pi h. Now, what is dV over dt? That's going to be, pi is a constant, so pi times dH over dt. And what is dH over dt? Well, they give to us the problem right here. So replacing that, we get pi times negative 1 over 10 radical h. Now we're looking for dV over dt when h is 4. Well, that gives us, when you plug in 4, what do you get? Well, you get negative 2 pi over 10. On the FRQ, you don't have to simplify. You just have to live like that. If you simplify, you should get negative pi over. And it says indicate units of measure. So it's going to be negative pi over 5 feet cubed, because of volume, change of volume over time. It's going to be negative pi over 5 feet cubed over second. Now let's take a look at part B. Part B says when the height of the water is 3 feet, is the rate of change of the height, which is dH over dt, equals negative 1 over 10 radical h. Is the rate of change of the height of the water with respect to time increasing or decreasing? Explain your reasoning. So basically, we need to find this represents the rate of change of the height with respect to time. Is this increasing when h is 3? In order to find out whether dH dt is increasing or decreasing, we need to find the derivative of dH over dt, which is this. So when you take the derivative, I want to rewrite it as negative 1 over 10 h to the 1 half. So you will get negative 1 over 10 times 1 over 2 h to the negative 1 half. Now remember, you have to use the implicit differentiation. What is the derivative of h with respect to time? Well, that's going to be dH dt. Just think about the chain rule. This came from taking the derivative of h with respect to time. So you will get negative 1 over 10 times 1 over 2 over radical h times, what is dh over dt? Well, it's given right here. Negative 1 over 10 radical h. Radical h will cancel out. Negative times negative is positive. So you end up getting 1 over 200. So notice, no matter what, it doesn't matter what h is because there's no h to plug in. No matter what h is, the rate of change of dh over dt is always going to be positive. So what does it mean? That means since dh over dt represents rate of change of the height with respect to time, the rate of change of the height will always be increasing. So when h equals 3, the rate of change of the height will be increasing. That's your explanation, and you have to write it down on the test. Now let's look at part C. It says at time t equals 0 seconds, the height of the water is 5 feet. And notice it says use separation of variables to find an expression for h in terms of t. So this is a separation of variable problem. And that information right here will help us to find the value of c, a particular solution. So we know that dh dt is negative radical h over 10. We need to separate the variables. So it'll be dh over radical h equals negative dt over 10. Now remember, whenever we do the separation of variable, dh and dt, they have to be numerators, not denominators. So let me rewrite this as h to the negative 1/2 dh equals negative dt over 10. Now let's take the antiderivative. What do you get? You get h to the 1/2 divided by 1 over 2, which is the same thing as 2h to the 1/2 equals negative 1 over 10 t plus c1. Now at this point, I'd like to find what c1 is. I mean, instead of c1, you could say c. It doesn't really matter. Let's plug in the values. So h is 5, 2 radical 5 is, t is 0, so that's going to be 0, which means c1 is 2 radical 5. So when I plug it in, you get 2h to the 1/2 is negative 1 over 10 t plus 2 radical 5. Let's divide everything by 2, or when you divide everything by 2, it's like same thing as multiplying by 1/2. When you do that, you will get negative 1 over 20 t plus radical 5. So how do you get rid of 1 over 2 exponent? Well, you have to square everything. You get h equals quantity negative 1 over 20 t plus radical 5 squared. And that is your h in terms of t.